Hi, welcome to the Chicago Regional Engineering Design and Development Showcase. My name is Tony Tegtmeyer, EDD teacher at Neuqua Valley High School. I want to start with some thank yous. Thank you first of all to Project Lead the Way for providing so much support and curriculum updates throughout the year that made our job so much easier. To our judges and sponsors, North Central College, Molex, and Lindy for providing not only your support and encouragement, but judges, and in Lindy's case, thank you so much for your scholarship money. To my fellow teachers, Michael DeWeese and Brandy Palmerin, working with you has been nothing but a pleasure, and I always learn something from you. Finally, our administrators for allowing us to have this program here that's so valuable for our kids. And no thank you would be complete without thanking parents for allowing your children to be part of this amazing program. I also want to congratulate all of our finalists, the 9 finalists from the 3 schools. To my students, I just want to say, you're awesome. I've loved working with you this year, and you're going to take away what you've learned in this class, and you can apply it anywhere. We have persevered and got things done when I didn't even know if we could. But you guys were so awesome. I'm so proud of you, and you're going to go off and do amazing things if you choose to. So what is the contest, and what are you going to see tonight? The teachers, the 3 of us, got together and determined 3 finalists from each school, Downers Grove South, St. Charles East, and Neuqua Valley. Then we turned over the 3 finalists from each school to our judges from Lindy, Molex, and North Central College. So what you're going to hear tonight is a brief message from the sponsors and judges, and then you're going to see the full videos from each of the top 3 place winners. By the way, each of the top 3 place winners are eligible and will win a scholarship money.
Hi, and welcome to the 2021 Chicago Regional Engineering Design and Development Showcase. My name is Rocky Valadez, and I have the privilege to serve as a Vice President of Engagement at Project Lead the Way. I'm very excited to be with you and be a part of this event. In my role at PLTW, I have the opportunity to work with students, educators, and our business partners all across the nation. And if I've learned anything over the last year, it's that STEM education and opportunity is more important and relevant than ever before. This year, we've watched as schools and communities have had to apply the engineering design process just to make it through their day. Iteration after iteration, we've seen adaptation, testing, and continuous improvement become a part of our lives as we've navigated this school year. And I can say without hesitation that we at Project Lead the Way are so very proud of the work that you've done. The fact that you're a part of this showcase today shows your ability to overcome the obstacles and challenges that have been laid before you. And we're confident that you are the next generation of leaders and innovators who will address and remedy the world's problems. At Project Lead the Way, we know that global and local challenges surround us all. To address these issues, we'll need people who can work strategically, think critically and creatively, communicate and collaborate with others, and persevere even when things don't go their way the first time. Our goal is to help equip and prepare the students of today with the skills necessary to thrive in the evolving world of tomorrow. The problems you've solved for and the projects you've submitted are just the start of your contribution to the world. And whether you realize it or not, your experience in your EDD classroom is mirroring the approach that today's changemakers are utilizing each and every day to tackle some of the world's biggest challenges. You are truly on your way to engineering our future, and to that we say congratulations. Please know that we at Project Lead the Way commend you and your teachers for your steadfast dedication to your work and excellence this year, and we're excited to see what you'll accomplish next. Best of luck to each of you in this showcase.
Hi, I'm Amit Desh.
I'm Akshat Maheshwari.
And I'm Naveen Bachi, and we're here today to present our solution to improve firefighter health.
Firefighters are at an increased risk of lung and heart cancer due to their heavy exposure to harmful toxins and carcinogens known as polycyclic aromatic hydrocarbons, or PAHs. These PAHs seep through the outer shells of the firefighter's gear and are absorbed through the skin. As shown through a study conducted by the University of Ottawa, after fighting a fire, firefighters had 3 to 5 times the levels of PAHs, all which have deadly long-term side effects. The main reason due to this absorption of PAHs in their skin is due to the improper gear and clothing. In our research, our team contacted the fire chief of Naperville, Mark Puckinitis, and he commented that in addition to the hazards of carcinogens, their current gear is very bulky and cumbersome. As a result, we wanted to make a product that creates a better seal for PAHs, but still be maneuverable for the firefighters.
In the initial stages of designing and brainstorming, the team came up with 6 major ideas, ranging from gloves to jackets. These ideas aimed at tackling the problem of carcinogen exposure. Then, the team came up with 9 constraints, the 3 most important being performance, safety and durability, and maneuverability. After that, the original brainstorming ideas were put into a decision matrix, and in conjunction with survey results, the team concluded that the most viable product to design would be the glove and cuff system. So, our product contains 2 major parts. The first part is the cuff system with 2 Velcro straps. These Velcro straps make it easy to attach the glove and also add added dexterity by scrunching up the sleeve. The second part is the glove, and the firefighter can simply put the glove on and attach it to the cuff via Velcro. The whole thing takes 15 seconds to put on. The glove itself has 2 major layers. The first adds an extra layer of heat protection, which still allows you to carry bigger objects and people. It can be removed, however, so that the firefighter can have added dexterity and use tools such as hammers and axes. Another reflective material is added on top in cases of low light situations.
While working with the firefighters, a survey was conducted in which the firefighters stated that the most potential for improvement was the glove. One of the main problems with the glove was the holes that allowed for more air and carcinogens to pass through. So it was extremely important that we created this 3D printed cuff system that prevented carcinogens from passing through the glove. During the building and testing phase, it was important that we met and carried out all the necessary procedures and standards in order to make sure that our prototype was effective and functioning. The building phase was simple and efficient as it only had 3 major parts. The outer glove, which is the blue material in the left picture, the inner glove, which is the yellow glove on the left picture, and the rod and cuff design that we 3D printed in the middle picture. Finally, these 3 parts were combined to create the final design you see on the right. The testing phase had some major tests such as temperature, air pressure, and dexterity in order to make sure that these would all function under the extreme conditions of firefighting. A test we were unable to effectively carry out was the durability test, as that requires long periods of time that we were unable to carry out with the limitations on this current experiment.
The major limitations in our entire process was the inability to accurately test for temperature and air pressure, as we utilized an oven and hair dryer with an air pressure sensor respectively, since we didn't have the necessary equipment to do so. Additionally, due to time constraints, we were unable to have firefighters test out the product. With their feedback and testing the product in real firefighting situations, the additional iterations and designs will make a fully functional product in the future.
So this product will be marketed towards firefighters and fire departments. It will cost around $50 to make when produced in bulk, and will sell on the open market for around $99.99. That price point is competitive with most other gloves, which are selling around $99 to $110. However, this glove with this dual layer and cuff system could become the top product on the market because of the added features at the same price point.
Thanks for watching. Hope you guys enjoyed our presentation.
Greetings. I'm Richard Novak, representing Lindy, an event sponsor. My Lindy colleagues and I served as judges, and we provided a grant for scholarships. Here I am handing over the check to Mr. Tegtmeyer. You may be wondering, who is Lindy? Let me tell you. In 1895, a German engineer, Carl von Lindy, developed a way to separate air into other gases. That's right, through innovative engineering, he found ways to make money out of thin air. How are our gas products used today? Oxygen is vital in the production of materials such as steel, glass, and paper. Hydrogen in the production of oil, gas, and many chemicals. Gases are used in nearly all manufacturing industries. In healthcare, we provide oxygen to hospitals, particularly important in this pandemic. The electronic devices you're using to watch this presentation was made with our gases. We make green hydrogen from solar power as a transportation fuel. Gases are used to 3D print metal parts for aerospace. We can all relate to food. Oxygen is used for aquaculture, CO2 for greenhouses, liquid nitrogen to freeze food. When you open that bag of lettuce or potato chips, that's not air inside, it's our nitrogen, preserving freshness. And of course, we put the fizz in your soda pop with CO2. Technology like this has enabled Linde to grow to become a global company with sales of $27 billion, over 80,000 employees, and operating in over 100 countries. Linde has a strong tradition of giving and community engagement. We provide grants to charitable organizations, and our employees volunteer to help as well. I hope this presentation has shown how engineering can help solve problems and improve our lives. It used to be said that with an engineering education, the sky's the limit, but not any longer. Our gases are used to 3D print rocket engines, to fuel thrusters to keep satellites in orbit, and when those rockets blast off, they are fueled by our gases. If you decide to become engineers, welcome. I hope you use those skills to tackle tough problems, to help make the world a better place, and to follow your dreams. Good luck.
Good evening. My name is Michael DeWeese, and I would like to welcome you to the Engineering Design and Development Showcase. I'd like to start by thanking our sponsors, the judges, the students, Anthony Tegtmeyer and Brandy Palmerin, and Lisa Trout who put the celebration together. Engineering Design and Development is a capstone course in the Project Lead the Way curriculum. By the time the students are ready to take EDD, they will have completed at least 2 years of Project Lead the Way courses. EDD challenges students to apply their learned knowledge from all of their high school classes and come up with a unique and innovative solution to the problem they identify. They work the entire year to solve this problem, and this is a celebration of that year. I'd like to congratulate the 3 teams chosen to represent East High School this year: Home Hydroponic System, WGB Charger, and Mod Cube. Good luck. I would also like to congratulate all the teams at East who persisted and produced quality products. It's a wildly difficult year, but somehow you managed to be successful. I applaud all of the teams from the 3 schools. Please enjoy the ceremony, and thank you for attending.
Hi, we are the Green Engineering team, and this is our product, the Smart Can. I'm C.J. Joseph, and the Smart Can autonomously sorts between trash and recyclable materials, like this water bottle. Erring on the side of caution, the Smart Can allows for a pure recyclable output, no matter the input, like these apple cores. So what problem does the Smart Can actually solve? It solves the problem of reducing contamination rates of recycled materials. According to Rubicon, a platform that consults with government and small businesses about their recycling solution, only 30% of the recyclable materials in America is recycled. The research team of the University of Michigan says that the main reason this occurs is due to the many instances of recycled materials being landfilled due to contamination. This chart shows the composition of the landfilled materials from 2018. As you can see, well over 35% of the materials are recyclable. Our product would prevent from these recyclable materials from entering landfills. The Smart Can improves life by allowing less recyclable material to enter landfill. This results in less water, air, and soil pollution. It also allows for a pure recyclable output, reducing energy and time for recycle centers and increasing recycling rates. Based on our survey results, a large majority of people are more likely to recycle if the process was made easier and more convenient. This is why we developed a design that is more user-friendly and autonomous.
So by now you're probably wondering how our product, the Smart Can, actually works. Hi, my name is Rishi King, and all the functional components of the Smart Can basically revolve around this Arduino camera. What it's currently doing is sending a live video feed through my computer through a Wi-Fi signal, which means it's completely wireless aside from a small cable that you need to plug into the Arduino board, which provides power to the whole system. Once my computer receives a live video feed from the camera, it lies and waits until an object is placed into the frame of the camera. Once it detects an object, it takes a still image of that frame and sends it to my image recognition software. And what that is, it's basically an artificial intelligence system developed with around 2,500 images of various cardboard, plastics, papers, and trash products. Once it determines whether a product that's placed in the can is recyclable or trash, it sends a command to the Arduino, and that spins a stepper motor accordingly to dispose of the product in the trash or recycling compartments of the smart can. Once you dispose of your item, and then the can reads it and disposes of it, all you need to do to retrieve your product is press one simple button and grab your trash bag and dispose of it in your normal facilities.
Our prototype cost us $100 to manufacture. With further development, we hope to get that price down to $50 and have our selling point set at $100. $100 is half the price of our leading competitors' models. In the future, we hope to use factory to direct distribution to deliver our product to our customers all throughout the nation. By cutting out the middleman, we can reduce our price even further. Additionally, our AI software can be implemented into many different types of trash cans, making our proprietary software scalable and allowing us to reach a wider audience of customers. In addition to that, we can sell our product in bulk to our bigger customers, such as schools and cities. Our product has a wide range of target customers, such as cities, airports, schools, and homes. The product can be implemented in city, airport, and schools trash cans throughout their hallways, streets, and corridors. At home, it can be implemented into the trash can you may have in your kitchen or bathroom, and a smaller scale of our current model. Additionally, with minimal tweaking, our AI software can be tweaked to sort a variety of different materials beyond just trash and recycling, making our product have a lot of applications.
Now that you've learned about the Smart Can, you may be wondering, why not just use 2 cans for recycling and trash? Well, by using an automated system, the Smart Can can guarantee a pure output of recyclable materials on one of its containers. This can be sent directly to the recycling facilities, cutting out any chance for human error and contaminating a clean batch. In the future, we hope to make many improvements to the Smart Can. One such improvement would be a smaller electronics board, minimizing the profile of our current product. Additionally, we would like to upgrade our AI, increasing its accuracy from our current 84% and allowing it to sort multiple items at once rather than its current individual input.
From everyone at the Green Engineering team, thank you for watching.
Hello, I'm Erica Holm, Program Manager for the Molex Community Engagement Program. On behalf of Molex, we are excited to collaborate and support your organization. We strive to drive virtuous cycles of mutual benefit in our community because it is our community vision to create opportunities that transform society. To do this, we leverage our strengths to help solve tomorrow's toughest challenges, and we're starting in our communities. Molex focuses our community engagement energy around 4 key impact pillars, and those are STEAM and education, innovation and entrepreneurship, empowering our neighbors, and advancing health and wellness. We are excited to be supporting Project Lead the Way with North Central College, and it is our hope that we empower others and foster inspiration and inclusiveness through our community engagement. Thank you for providing us with this opportunity.
My name is Brandy Palmerin, and I'm one of the engineering, design, and development teachers that were part of this showcase. And first, I just want to say thank you to all the students that were involved. I thought your ideas were very innovative, and your videos were super professional, so kudos to all of you. I more specifically, though, want to give a shout out to my Downers Grove South Mustangs. This has been a year, a crazy year, as we all know. You were able to come together to create a prototype, even though we had much less in-person time than years past. You were able to figure out your presentation. You guys really went above and beyond. So I am very, very grateful of all of your hard work. And this will be a class that I will tell other classes about. I just really was impressed with not only your professionalism, but your motivation and your dedication to this class. So from the bottom of my heart, Mustangs, thank you so much for making this class an amazing one.
Hi Sharks, I'm Aaron Mars. I'm Dylan Coles.
And I'm Krishna Patel.
And this is the Speed Bump Camera Project.
Our project prioritizes people's safety. Approximately 70,000 people a year are either killed or injured due to speed violations and people running stop signs. These injuries could have easily been avoided had drivers had a deterrent to ultimately prioritize people's safety.
Our problem is based off people who refuse to obey traffic laws, especially when it comes to halting at stop signs.
This video is an example of how our speed bump could have prevented an accident. As you can see, this gray car flies right through the intersection and slams into the red car. Had there been some type of physical deterrent to slow down this car, this accident could have easily been avoided.
As you can see on the right, there are two laser velocity sensors that will detect the speed of an incoming car. If the car is going over 10 miles per hour, it'll tell the camera to take a picture of the car passing over the speed bump to allow us to get the license plate of the car.
To show you how our speed bump works, we drove over our speed bump at 20 miles an hour in order to trigger the speed bump. As you can see in the velocity sensor, we drove over at 20 miles per hour, and thus it took a picture of the car and therefore has done its job.
A similar product, the red light camera, deters people from running red lights, but the problem with these are that they cost upwards to hundreds of thousands of dollars for just one. Along with the red light cameras are the speed indicator signs. These also cost upwards to thousands of dollars, and they don't even take a picture of an incoming car that's going over the speed limit. Compared to our products, these two can cost upwards of thousands of dollars, while ours only costs a fraction of that. In addition, those two products are only stationary, while our speed bump is portable and can be easily moved wherever you need.
I probably, I think school zones are most prevalent. That's where you see a lot of the deterrent type products, either posted on a speed limit sign with flashing lights that notifies people when they're going 10 to 15 over. That's typically where you see the most signage. And we've done traffic studies here around the school that show the schools being most prevalent, but really this could be marketed anywhere. Any side street in town has issues with stop signs and speeding vehicles. So, the possibilities are endless.
So our biggest concern here is how the police department and the schools could operate together in order to put them onto the streets right around our school here and make sure that we're prioritizing safety.
Yeah, because these could, if this was permanent around a school, it'd be perfect. If it could be used as a deterrent in other areas, we get probably 5 to 10 traffic complaints a week in different areas, but school zones are most prevalent. So the fact that you could be monitoring, it could be a deterrent as far as the speed bump goes. Somebody would probably slow down prior to reaching it, but then on the back end, the having some reliability with the speed and then capturing the photo of the license plate could be used for prevention later on, sending them a letter, or even enforcement further down the line is a huge benefit. The fact that they're portable and you could put them in target areas, because maybe, for instance, right now this isn't an issue here at South High, but it could be at Kingsley School next week or another area, depending on what's going on. So I think it's just, it's an extremely valuable tool.
In the wake of Beth Dunlap, a Downers Grove North student tragically killed by a reckless driver, Principal Edward Schwartz was a strong believer in the project, and he also reiterated the fact that school zones should become a priority for this final design. Thank you, Sharks, for taking the time to watch our presentation. We hope you understand the importance of this product, and we hope you consider investment. Thank you.
Wasn't that great? Congratulations to all of our finalists, and particularly our top 3 place winners. 3rd place, the firefighter safety team from Neuqua Valley. 2nd place, the Smart Can team from Neuqua Valley. And our grand champions, the Speed Bump Project from Downers Grove South. Thank you for watching, and I hope to see you next year in person.